It's not. This part's easier than yesterday, so that's a good thing. What'd you say?
Isn't it equal to 0?
That's called the discontinuity, but let's talk about the degree.
We need to understand yesterday to understand today, right?
No. This is what we're doing, so let me kind of explain this chapter a little bit more. So really, you're only doing one problem, but we're breaking it up into pieces. So like, I'm going to ask you to identify all the characteristics of this function. And every day that we're just taking one single day on each part of the characteristics. Okay, so yesterday is just one characteristic. That's your discontinuities. We're going to do another discontinuity, but it's different. Okay, so each piece you don't need to know the other for. Okay, but they all are going to tie together on that last day next week. And you'll see how that goes. It's pretty cool. So we're taking one step at a time, one day at a time. So let's first talk about, this one's horizontal. Yesterday we did vertical. Horizontal we're doing today. Okay, so that's your y values. Okay, your y values. Horizontal asymptote, your equations would be like y equals 1, y equals 2, y equals 3, etc. So the degree of a polynomial is the largest exponent. We practiced that when we were talking about polynomial functions in chapter 5. We talked about that largest exponent, the degree of it. Okay, remember I was like, hey, what's the degree of the function? You're like, oh, it's even, so it's going to open up in the same direction. That's kind of the same thing. We're going to do the largest exponent. So let's look at this one. What's the degree of number 1?
A 3.
A 3. So with the highlighter, I want you to highlight 3. And yeah, I'm going to highlight degree too so that you know that that goes together. So my answer is 3. That's it for that one. I'm just kind of warming you up to what we're about to do. What is the degree for number 2?
2.
4. You see how 4 is higher?
So it has to be the highest.
Okay. So 4 would be my largest. It would be my degree of the polynomial. Okay, number 3.
That's it?
That's it for right now. What's my degree of number 3?
2.
2. Okay. I want you to do 4, 5, and 6, and I'll give you tickets for it. The only one that's a little bit of a trickster is 6. So this one has any x's. So what do you think? It doesn't have any. See how this one has 1? This one has nothing.
Can you just put 0?
Yes, you can. That's it? Yep. You have to get all 3 of them right to get a ticket.
Done.
Check 5.
5. I knew it. I had that first.
Okay.
Fight.
4, 5, and 6.
1, 5, 0.
How many x's?
So the x's count?
X's are what you're looking at.
So when this one becomes over, you always have to see this one.
Yes, you're basically saying how many x's do I have? I have 1. I have 5. I don't have any.
Is there power in front of x's?
You can't just see that.
Yeah, but no degree.
Yes, that's for the actual.
I told you. We had a big debate yesterday.
Get there. I get there too.
I do not have to leave around 8.
I don't know.
Because I gotta get up at 5.
How many x's does this guy have?
Two next to the box.
Okay, got it. How many does this one have?
And I was never a hood, so it's the one in front of me.
Oh.
Good. What is a really large pencil?
You stole it from building trades. I'm gonna tell
You
Mr.
stole it from
Davis.
Village Trade?
Oh.
Stealing is
How many
bad for you.
x's do I have?
He's a nice man.
There's an x here?
Oh, Mr. Davis hates my class.
Oh, he loves us.
He hates us.
He always does my work for me.
I told him a bunch of things like, oh, he's a big kid.
All right.
Like, really shady wise. Like, I was like, oh.
He hates our class.
I actually was going to ask you, can you make, I only need 15 for next hour. I didn't have time. But whatever I scanned, just 15 of them. 16 actually. That one won't have staples. But yeah. You just press print and then you would just scan it. You just copy, yeah. Okay, so you guys did good. Look. Listen, listen, listen. Okay, there is only one. Kind of count your X's. I only have one x here. It's my largest one. I have, the largest one's 5, but that's how many I have. I have 5 x's there. Here I have none. I have 0 x's, so 0 is my degree. Okay, a lot of people get stumped on 6, but if there are no x's, there is no degree. Okay, so that's going to help you a lot when you're doing this problem, and I think you guys will be really good at it because it's pretty straightforward. Basically what we just did. Okay, so a horizontal asymptote is a y value on the graph that a function approaches but never touches. Just like vertical. So a vertical asymptote is this way and a horizontal is this way. Okay, so I'm going to zoom into this graph really quick. Do you see here on this graph the function is slowly going towards it but never going to touch it? That's called a horizontal asymptote. The function slowly goes there but just never ever actually touches it. And if you look on your graphing calculator, it'll tell you it does not exist there. It'll say error right there. Okay? All right, so let's actually talk about it. There are 3 conditions that we'll put in your interactive notebook on Friday. If you want to memorize them, great. If not, this chart is going to be going in your interactive notebook for you to reference. Okay? So the condition, if the degree of the denominator is larger, I'm going to highlight that because that's the key there, the denominator. If the denominator is larger than the degree of the numerator, our horizontal asymptote will always be y equals 0. Now I'm going to explain that to you with the example I see. If you look here, do you see how the top, what's the degree of the top? 1, right? Which is only one of them. What's the degree of the bottom?
2.
So 2 is higher than 1. So that means my asymptote will be at y equals 0. That's just a fact that I'm going to give to you and that you need to know or be able to reference.
Can you go back to how did you get y equals 0?
So it's just one of those laws of mathematics. If the degree is larger, 2, on the bottom, you automatically have an asymptote at y equals 0.
Okay.
If it's on the bottom.
If it's on the bottom,
Okay.
yes.
On the top, it's
We're going to talk about that.
Okay.
Okay? So now, let's just do the opposite right now. Let's go to the third one. If the degree of the numerator is larger, so here, if the degree of the numerator is larger, so if you look here, the degree on the top is cubed, and the degree on the bottom is squared. So the 3 is obviously higher. Then you automatically have no asymptote. So those are the 2 that are very straightforward. That's just the rules of mathematics. No matter what you do, if the degree is higher on the top, you're going to have no asymptote. You'll have no restrictions on those y values, is what that means. So highlight that, and then highlight this guy too, just so that you know that the degree was higher on the top there. Now the only one that's a little bit different is when they're the same, because it's a little bit harder to see when they're the same. So this is the only one that I feel like might be a little bit more challenging, but I think a lot of you will do just fine. If the degrees are the same, we'll fill in that spot. Okay, so if you look here, the degree is 2 and the degree is 2. So they're the same. What you have to do is just take the leading coefficients. What does that mean? The 2 all the way out in front. What number is all the way out in front here? A 1. Very good. So let's do this example off to the side. I'm going to take my highlighter. It's always the leading coefficients. So I have y equals 2 divided by 1. What is that? 2, and that's it. So it's not hard, you just have to remember to do that. So that's the only one that you have to do a little bit of work to find it. So if they're the same, all you do is you take the numbers all the way out in front and divide them. That's it. Okay? Questions on that? Those are the 3 things you need to know, or we'll put it in your interactive notebook, you'll be able to reference it. Okay, so as long as you can read a chart and reference something, you really don't have to memorize it. Okay. I want you, it's a quick way to kind of remember, think that, oh my God, I highlighted the wrong one. You're guys are going to kill me. I'm so sorry. This guy was supposed to be highlighted. Okay, because it's a denominator. I am so sorry.
Oh,
I know, I'm so sorry. I feel bad. I have whiteout if you want to white it out and write it.
Wait, what?
I have whiteout if you want to white it out and write it.
White out.
Okay, So, think if the denominator is bigger, see, denominator, then you're going to have y equals 0. So, hold on a second. There they are.
Hey, that's what's dodgy. No wonder.
Anyone else want white out?
Oh, you don't have the liquid one?
Alright, anyone else want white out for their highlighter?
This is fancy.
Just pass them to someone else that wants it if you do. Okay.
No.
Give everyone a second, I apologize for ruining your notes there.
That is nice.
Wait, what, I'm confused. What?
Yeah.
So originally I highlighted this and it was my fault. I highlighted the wrong one because the degree is large on the bottom. I think I was just going based off of what I just did earlier, but it was supposed to be this guy, and that's why if you want a whiteout, they're passing him around. That's all.
Okay.
Okay. All right, I'm moving on. Okay, this one, here we go.
What out? It works good, man.
It does. Let's take a look at number 1. What's the degree? This is what I want you guys to think when you do this. What's the degree of the top or the numerator? 2. What's the degree? So I'm going to circle that or highlight that piece. Just the 2. And the degree on the bottom is also 2. So they're even. So am I going to have 0, none, or do I have to do the ratio?
A ratio?
The ratio, very good. So I'm going to circle this piece just to help you out. So what is 9 divided by 3? That's it. You found it. Okay, so it's pretty straightforward. Just teaching you the basic steps of it, and then we will do other things with it in the future. Okay? Do it again. Now, this is where it might get a little challenging. Okay? How many X's do you see total on the top?
4?
On the top.
Oh, on top 2.
So there's 2 here. Good. And then there's another one here.
But that
So
one doesn't count.
it does though, it's on the top. As long as, because when you actually, hold on. When you actually look at it and you multiply, it would be x cubed. So that's why. Or you can just count them. So I have 2. I'll even write that on the top. I have 1 plus 2, which gets me 3. So that's my degree on the top. What is it on the bottom?
Oh, just 1.
So is it higher on the top, bottom, or the same?
Top.
The top. So go back to your chart and see what automatically is your horizontal asymptote if your numerator is higher.
Wait, where'd you get the 1 and 2 from Adam to get the 3?
Hey.
Sorry.
So you see how x to the first power, x to the second?
Oh,
To find the degree, you add them.
okay.
Okay? So is it higher on top, bottom?
None.
There is none. Very good. It's higher on the top, which means I have none. There is none because that's just the rule of math that I gave it to you on the first page. But now I'm going to ask you really quick, discontinuities. I'm trying to challenge you from yesterday. Whenever you think discontinuities, I want you to think denominator, D and D. Discontinuity, denominator. So I'm going to go straight to the denominator like we did yesterday. What makes the bottom equal to 0?
Because it's a negative.
What,
And it crosses on the x-axis.
but we need to find the number. What makes the bottom? This is what we did yesterday. So
Yeah, plus,
yeah, so I have x minus 5 equals 0.
which is 5.
Very good, which is x equals 5. And that's my discontinuity. That was from yesterday, just to kind of bring it a little bit back from yesterday. Remember, discontinuities is what makes the denominator 0. Well, if I plug 5 in, 5 minus 5 is 0. That's why it works. You could have just figured that out without doing this. I'm okay with that. If you can figure that out without solving, that's fine. Can anyone tell me if it's a vertical asymptote or a hole?
It's a whole.
It is a hole. Very good. Why? So this is kind of just like, I'm not asking you to do this right now because I didn't ask you for it, but
Why?
go ahead.
Because the -5 and the 5, you can cross them out to create a hole.
The -5 and the 5. So let me kind of go for the,
Because isn't it a whole number? Like,
it's not a whole number.
um,
What does this factor into?
5.
It's only 5 and 5.
The 5, but you're saying 5. I'm not really understanding what you mean by 5. You take the square root. How did we write that? I'm trying to get you guys to think more. How do I write this when I factor it out? For the bell ringer yesterday. Think bell ringer from yesterday. Well, how do we write that?
X plus.
Good.
Whatever, X plus.
Good.
Whatever.
This is the one thing I need you guys to know for this chapter. It's how to factor just this. It's the easiest one of factoring. And if you notice, look, I have an x minus 5 on top and an x minus 5 on bottom. They cancel. So this technically would be a whole. I didn't ask you for that, but I was trying to challenge you to see if you remembered a little bit from yesterday. But I don't want to overwhelm you by doing too many things at one time. I just wanted to see where you stood at that point. So we need a little bit more help with that
It's a whole
factoring.
because you can do X plus 5, X minus 5, right?
It's a whole because I can cancel this
That's what I was trying to say.
with the top one.
Okay.
That's why. So the moment you remove something from your problem, it's called a removable discontinuity, which technically is a whole. So the moment you make the crossing like that, you have now created a hole in your graph. Okay? So that was just from yesterday. Well, we will go over that more tomorrow. Or I'm sorry, on Friday. Let's do this one though. What is the degree of the top of 3?
Just X.
Which is 1. What's the degree on the bottom?
2.
So what is it, higher on the top or bottom?
Bottom.
So what automatically is my asymptote if the degree is higher on the denominator?
Y equals 0.
Very good. So as long as you can go back and reference your chart on the previous page, you will be fine. And I'm going to highlight this because the degree is higher on the bottom. That's why. Now let's talk about our discontinuities. This is from yesterday, so that's all you learned today. Now let's talk about yesterday, 'cause I'm going to keep reviewing it with you till you get it. How do I factor, remember, discontinuities, denominator. What can I take out of both of these that's the same?
X.
An x. You always have to factor when you do discontinuities if you can. Okay, if you can do it, you have to factor. What am I left with inside?
1 X. I'm just X. Yeah.
Just x and then
-7.
negative
Plus 7.
plus 7. Here's how you check that. Look, x times x is x squared. X times 7 is 7x. We're good. Okay, so now we can figure out the discontinuities because it's a lot easier. Here's how you do that. Remember, you set both of them equal to 0 in pink and in blue. What makes this one equal to 0? For some reason, everyone gets tricked with that one. For these ones, I'm going to help you out, just this guy.
-7.
That's this one, yep. So this is x can't be -7, you're right. What about this one? What number would I have to plug into this pink part to make it 0? It's not a trick question. It's 0, yep. X can't be 0. Do you see how if I put 0 here, I get 0? Okay, a lot of people get that one wrong because it's just like an x. Don't want that one's actually a pretty easy one. And I'm just going to draw, like, square it off and it goes there. Because that's how we got it. Do any of them cancel? Look, does x cancel with anything up here? No, because you have to cancel a whole group. Does 7? Do you have exactly x plus 7 up here?
No.
No, so they're both vertical asymptotes. That was from yesterday. Trying to like keep giving you practice of things that we're doing in class. All right, let's do it again. I want you to do this horizontal asymptote for a ticket. It's pretty easy. It's an easy one. I'm not asking for the discontinuities. I'm just asking for what we learned today. You always ask yourself, is the degree higher in the top, bottom, same, and then go to your chart and figure out what you have to do. Like if I draw a line this way, you know that's horizontal, right? This way? That's your y values. It's not the axis, it's the y. So let me so this is right. A lot of you got it. Y equals 0. But let me kind of just sketch you a graph so that you understand this. So no phones, just eyes. Because this stuff is too hard for you to get distracted with. I just want to explain to you what this is. That's all. Your y equals 0 means, and we're going to do graphing a different day, that there's this thing called a horizontal asymptote like this, a pink. Do you see how that's y equals 0? This would be like y equals 1, 2, okay, that's your y. What's going to happen is that your graph is going to slowly go towards it, but never touch it. It's like a wall. It can't hit it. And we'll talk more about that when we get to the graphing part. Just trying to do the basics with you right now. Okay, so let's look at this one. I want you to do this one too. Do number 5 and 6. You for sure can do 5. You can actually do all of them. I want you to do all of them. 5, 6, 7, and 8. You can work with someone or work alone. Because I need to know if I need to help you right now. Do you need more help right now? You guys did a very, very, very good job. You're working hard. It makes me happy. You're helping each other out. This stuff, like I said, is not hard. It's just new. It's new. You're getting used to it. Okay. So the horizontal asymptote for this first one. Some people got a little tricked up on it. It's the same degree, so I take the numbers all the way out in front. A lot of people are telling me that 0 is out in front in here. What number is out in front?
1.
A 1, so it's y equals 1/2. If you put 0.5, that's fine. Your discontinuity, what makes the denominator 0? What number times 2 gets me 0? What number times 2 gets me 0? 0. So y equals 0. Or sorry, x can't be 0. It's okay. I'll write this one out. You have 2x squared equals 0. Right? That's what we've been doing yesterday and today. My first step would be to divide. I get x squared equals 0. Do you see how no matter what I do to that side, I'm still going to get 0?
Yeah.
That's why it's 0. Because then I would take the square root, and I would still get 0. You can do 0.5. Yeah. All right, listen. Did someone ask a question? I don't know. What's up? So the discontinuities means denominator. You only look at the bottom. Okay? But that's a very common mistake. What's the horizontal asymptote of 6? A lot of you got it right. None. What about number 7?
Y equals 0.
Very good. Okay, what about this one?
None.
Ooh, yeah, it is none. Yeah, it can't be 6. Okay, so again, easy stuff, just new. Just take your time with it. That's it. You did it.
Okay,
Homework. You can finish it before you leave. You want to work at it.
No! Homework!
Few hints. What makes the denominator 0? What makes the denominator 0 here? What makes the denominator equal to 0? -1. Look, listen. Even if you're not listening, you need to be quiet so that people can listen. Whenever you're looking for discontinuities, you're asking what makes the bottom 0. And that was -1. So that is right here. That's the first thing I do. I always look at the bottom. I see what my discontinuities are.
So it's only one number, there's no 2?
It could be 2 numbers. It could be 3 numbers.
How would it be 2?
So for example, let's just kind of go to right here, number 5.
Oh, okay.
How many do I have to write here?
No, 2.
2. Let's go to, that's the only one I think in this problem that you're going to have 2. Now let's continue with number 1. Now, we have one of them. The goal is kind of how my brain works and how I really want your brain to work. Once you write your discontinuity, you need to decide, is it a whole or a vertical asymptote? And that's why I have it laid out this way. This either goes here or here. They're both discontinuities, but you need to figure out which one. So the question is, does this cancel with anything on top?
No, they're even. Oh, wait, yeah, no,
Yeah.
yeah.
Yes, they do. Look, this whole thing cancels with this whole thing.
Oh.
So that makes right there a whole. Okay, so if something cancels, it's a whole. So look, again, it's kind of like a process. You find your discontinuity and you say, is it a whole or an asymptote? Well, we just said it's a whole. So all I'm going to do is write the whole there. I'm going to just kind of go like this.
So then you don't have to answer the vertical.
Yeah, so I have none here. There are situations where you might have both.
Okay.
So that was yesterday. And I know that was hard yesterday. We're going to keep practicing. So the first step, find what makes the bottom 0 and say, does it belong here or does it belong here? That's what this is. We're going to get, that's the next one I'm going to do with you. It's going to be none because there's a bigger degree on the top. So that was what you learned today. This is what you learned today. I'll even write that down if you want to look at your notes. This was from today. This was from yesterday. Okay? So I'm trying to slowly get you to do these problems. And I don't give you a lot, and I factored them for you. I try to be nice. Here, right away, look at this one.
Yes, it's a whole.
It's a whole, look. Same thing on the bottom, same thing on top. That creates a whole. Okay?